Hello and welcome to Crazy Math Productions. Today we're going to continue our unit on quadratics and radical expressions. We're going to look today at applications of the discriminant. Now if you look, the discriminant itself is this part of the radicand. It's b squared minus 4ac, or it is rather the radicand, the radical being the symbol and the radicand being the part underneath, the expression underneath. So the discriminant, it's not saying that it's discriminating. It's a completely different concept. This is the discriminant. And what it's going to do is to tell us some very crucial information about the graph, about the solutions to this. It's going to tell us a lot about the quadratic equation that we're dealing with. And let's look at example 1. Now, remember that we're looking at b squared minus 4ac. Zoom in a little bit here. So if you look at y equals ax squared plus bx plus c, just to clarify, remember a is 1, that's in front of the x squared, b is negative 4, and c is 1. So b squared minus 4ac, so that's b, got to put that in parentheses, squared minus 4 times a times c. That's going to be 16 minus 4, or 12. So the discriminant is 12. The discriminant is positive. Now let's actually graph this. Now remember, to graph, we have to look at the x-coordinate of the vertex, which is going to be the opposite of b over 2a. In this case, b is negative 4, so the opposite of negative 4, over 2 times a, which is 1. The opposite of negative, that's going to be a positive. 2 times 1 is 2, and so 4 divided by 2 is 2. So my XY t-chart, I'm going to start with 2. That's going to be the center. And I'm going to go up 1, up 2, down 1, down 2. I'm just going to plug these things in. So y equals something squared minus 4 times something plus 1. Darken that so I can see it when I'm coming back. All right, let's go ahead and plug in 2. So 2 squared. 2 squared is 4 minus, that's going to be 8 plus 1. That's going to be negative 4 plus 1 is negative 3. Plug in, well, 0 is very easy to plug in. I love plugging in 0. So that's 0 minus 0 plus 1. So that's positive 1. Always love that. Very easy to work with. And 1 is pretty easy to work with too. So let's plug in 1. So 1 squared, that's going to be 1, minus 4 plus 1. That's negative 3 plus 1, or negative 2. If we've done everything the way that it should have run, we're going to notice that there should be some symmetry. Plug in 3. Now I'm going to plug in 3, and if I get negative 2, I know the symmetry here is working. We should have negative 2 here and positive 1 here. Then I don't need to fill this one in. I don't need to plug in 4. This should be working fine. So I'm going to plug in 3. So 3 squared is 9 minus 12 plus 1. 9 minus 12, negative 3, plus 1 is negative 2. And that is working. So I know my symmetry is in place. This is good. Now we just need to graph things. So 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, and 4, 1. And so this is an equals, this is an equation. Now, it never goes completely vertical. It's going to be easier said than done. Never goes completely vertical. Try not to make it vertical. Try not to have any corners. Try to see if you can do it smoothly. And of course, I wrote both of those rules, but it's just a sketch. So make sure it's smoothly curved. Try not to make it completely vertical, and make sure it goes off the graph. And so there we go. Now, you notice that it touches twice. Interesting. Solve the equation using quadratic formula. Well, x equals, we like to do pop goes the weasel, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we're going to plug in everything here. The opposite of b, which is negative 4, plus or minus the square root of b squared. Well, now, b squared minus 4ac is what I was dealing with here. That ended up being 12, so we can just go ahead and plug that in. Over 2 times a, well, a is 1. Opposite of negative 4, that's positive 4, plus or minus the square root of 12 over 2. Now, I can never leave the radical expression unsimplified. 12, if I break it up, is going to be 2 times 6, 2 times 3. So you notice we have square root of 12 is square root of 2 times 2 times 3. I see a pair of 2's, bring one of them out, and I have 2 square roots of 3. So this is 4 plus or minus 2 square roots of 3 over 2. This is a trick you really need to know. Because I have something that will reduce in all 3 highlighted areas, I can reduce that. So divide by 2, divided by 2, divided by 2. We're going to end up with 2 plus or minus 1 square roots of 3 over 1, or just simply x equals 2 plus or minus the square root of 3. Now think about it. The square root of 3 is about 2, a little less than. So 2 plus or minus 2 essentially is what we're dealing with. So 2 minus 2 would be about 0. You notice that hits at about 0. 2 plus 2 would be about 4. That hits at about 4. So what this has told me is that when my discriminant was positive, think about this in terms of the quadratic equation here. I'm adding 12 and adding the square root of 12, subtracting the square root of 12. That's going to give me 2 separate solutions. Well, that's exactly what the graph told me, that there were 2 places where it hit the x-axis. It also told me that since this was positive, there were 2 distinct solutions here. So, describe in complete sentences what we notice among the discriminant, the graph, and the solutions. Well, when the discriminant is positive, there will be two, you could call them roots or x-intercepts on the graph, and 2 solutions for x. And of course that's true for the real number system. That's the system that we deal with in Algebra 1. So when the discriminant is positive, we have 2 x-intercepts, or you could call those roots. We have 2 solutions to the quadratic equation, or actually to the equation itself. What if we have one like this? So again, from the last example, if the discriminant is positive, we have 2 roots, 2 x-intercepts, 2 solutions. Let's see what happens here. The value of the discriminant, b squared minus 4ac, well, b is negative 4, a is 1, and c is 4 this time. That's 16 minus 16, or 0, so the discriminant is 0. Let's see if anything changes on the graph. Well, we still have to do x equals the opposite of b over 2a. That's going to give me the x-coordinate of the vertex. X equals the opposite of b, so that's the opposite of negative 4, over 2 times a. The leading coefficient here is 1. Leading coefficient is the technical name for a. The opposite of negative 4, that's positive 4, divided by 2 is 2. So that will be the x-coordinate of my vertex. It's also going to be the center of my table of values here. So I'm going to go up 1, up 2, down 1, down 2 on my table of values. Now let's go ahead and plug these in. Zero is always very easy to work with, so let's go ahead and plug in 0. That's 0 minus 0 is 0, plus 4 is 4. 1 is usually runner-up as far as easy to work with. 1 squared is 1 minus 4 plus 4. Negative 4 plus 4 is 0, plus 1 is 1. Now let's try 2. 2 squared is 4 minus 8 plus 4. 4 plus 4, 8. Minus 8 is 0. Okay, we just need to try one of these. So let's try 3. 3 squared is 9 minus 12 plus 4. 9 minus 12 is negative 3, plus 4 is positive 1. You notice the symmetry is holding true here. This is good. So we can go ahead and assume that this is going to be 4. All right, we just need to graph these points. 2, 0, 4, 4, 0, 4, 3, 1, and 1, 1. And sorry, that was a little random. And I missed a little bit, but that'll do. So as we look at this graph, you notice that it only touches one place, and that is at 2. Let's see what happens with the quadratic formula. X equals the opposite of b. Well, b is negative 4, so opposite of negative 4, plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is 4, all over 2 times a. Remember, negative b plus or minus the square root of b squared minus 4ac, all over 2a. And that gives us our quadratic formula. So now we have opposite of negative 4, that's going to be a positive 4, plus or minus. Now you notice that this is the discriminant, which we had just worked on. We found that the value of the discriminant was 0, so I'm just going to go ahead and plug that in, save myself a little work. All over 2. Now here's the interesting part. We notice that it touched the x-axis only one time. So when I look at this, the square root of 0 is 0, and when I do 4 plus 0 and 4 minus 0, hopefully you would realize that that is the same thing. Adding 0 and subtracting 0 is the same thing. So 4 divided by 2 is 2. And you notice that this corroborates with what I had over here. The x-axis, the x-intercept, excuse me, is 2, and the solution is 2. They are related directly. So when the value of the discriminant is 0, I'm going to have it touch the x-axis one time. That is, there is one root or one x-intercept, and there's going to be one solution using the quadratic formula. So when the value of the discriminant is 0, there will be one root or x-intercept, and there will be one solution. And hopefully you realize that there is a very very deep connection between the algebra which is the quadratic formula, and the graphic method or tabular method, depending on how you're looking at it. Okay, last but not least, let's look at the discriminant now. Again, b squared minus 4ac. b is negative 2. Don't forget to put it in parentheses. A is 1, c is 3. b squared, so that is 4 minus 12. 4 minus 12 is negative 8. So the value of the discriminant is negative 8. Now we need to graph it. X equals the opposite of b, which is negative 2, over 2a, which is positive 1. Opposite of negative 2 is positive 2. 2 times 1 is 2, so we end up with 1. So the vertex, the x-coordinate, is 1. That will be the center of my table here, my x, y, t chart. So go up 1, up 2, down 1, down 2, and we simply want to plug these values in. So we'll start with 0. 0 is always very easy to work with. 0 squared is 0 minus 0 plus 3 is 3. Let's plug in 1. Again, I'm just going with the easiest ones first so that I make sure that I haven't made any careless mistakes. Careless mistakes, very easy to make. 1 squared is 1 minus 2 plus 3. 1 minus 2, negative 1, plus 3 is positive 2. And let's plug in negative 1. Be careful with this. Make sure that that negative 1 is in parentheses. It will matter. Negative 1 times negative 1 is positive 1. Negative 2 times negative 1, positive 2. And so 1 plus 2, 3 plus 3 is 6. Now all we need to check is that the symmetry holds. So if this is 3, then we know that this will be 6. So let's just try the 2 and see how it's working. Two squared is 4 minus 4 plus 3. 0 plus 3 is 3. And we have 6 here. And let's see how that works out. 3, 6. 2, 3. 1, 2. 0, 3. Negative 1, 6. And we're just going to graph this. Try your best not to have any corners. It's probably the best one I've done so far. And we're going to solve the equation using quadratic formula. Now, so far, looking at the sort of the connection that we've been making, how many intercepts are there? Well, there's none. The discriminant was negative. That meant there were no x-intercepts, no roots, depending on the vocabulary you're using. Let's see what that means for the quadratic formula. Now, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so, b is negative 2. The opposite of negative 2 plus or minus the square root of, well, we know that the discriminant is b squared minus 4ac. We worked that out and had negative 8, so let's just go ahead and put the negative 8 in there. 2 times a, so that's 2 times 1. The opposite of negative 2 is positive 2, plus or minus the square root of negative 8 over 2. Now we have a big problem here, which is the square root of negative 8. Now when we get to later math, we'll realize that this is an imaginary number, which is actually 2i onto the square root of 2. But we're just not there yet. In Algebra 1, we're dealing with a real number system, and so we will have no real solution. And I like to say no real solution because that does indicate that we're dealing just simply in the real numbers. There is a solution. It's just not a real number. So trying to connect these three, when the discriminant is negative, that means that it's never going to touch the x-axis. that also means that there's no roots, which also means there's no real solution. So connection here is that when the discriminant is negative, there will be no roots or x-intercepts. Again, those words being synonyms in this context. And there will be no real solution. So trying to connect the dots, when we looked over here, if the discriminant was positive, there will be two roots, that is two x-intercepts, and there will be two solutions to the equation. When the discriminant is 0, we know that there's going to be one x-intercept, one root, and one solution to the quadratic formula. But when the discriminant is negative, there will be no x-intercepts, no roots, and there will be no real solution. Thank you so much for watching Crazy Math Productions. Have a good day.